For Unit 6, Objective 3, the focus is on adding and subtracting radical terms, but we actually get into a little bit of multiplication too. Now I'm going to first start off with a related concept. When you add and subtract variable terms, we just have like this, 7x squared plus 5x squared. Well, the concept is combine like terms. The reason these two things can be added together is they're both terms of x squared. So 7x squared plus 5x squared simply is 12x squared. 19xy minus 3xy is 16xy. Now, 10x plus 3y, this is an example of how you can't simplify this anymore because they are not like terms. So if a problem asks you to simplify or add these two terms, you really can't. This is the most simplified form you can possibly get, 10x plus 3y. You just can't go any further than that. Well, the same idea holds true for radicals. I've got 12 square root 3x minus 10 square root of 3x. Well, they're both the same type of radical. They're both square roots of 3x. So 12 of these minus 10 of these is simply 2 of these, those being square root 3x. Now, this one, it looks like it might be able to be done, the very next one, but it can't. There's one thing that's keeping it from being done. This is a square root 3. Remember the invisible index of 2 right there? And this is a cube root of 3. So this is like the two terms, the 10x plus the 3y, that couldn't be added together. These cannot be added together either. So you can't simplify this down anymore. You would get as your answer 18 square root 3 plus 5 cube root 3. Now here's a typical problem. Once you get past the easy things that either can or cannot be added together, you're going to take a look at something like this. And at first glance, you wouldn't think they'd be able to be added together or subtracted because they're not the same square root. This one's square root 24, this one's square root 54, and this one is square root 6. But you can't make that determination until you simplify them all. So what we're going to do is we're going to simplify the 24 down to 2 times 12. And the 12 breaks down to 4 times 3. And the 4 breaks down to 2 times 2. So I've now prime factorized the square root of 24. Here's a pair of 2's. So one of them gets to come out. And when it comes out, it joins the 2 that's already out there. So 2 times 2 is 4. And what are we simplified down to? What didn't come out of the radical? This 2 and that 3. So what's left inside is square root 6. Now let's do the same thing to the 54. 54 is 9 times 6. 9 is 3 times 3. 6 can be broken down to 2 times 3. So there's the prime factorization. Here's a pair of 3's, which means one of them can come out. So, and there's nothing else out there, so it's 3 square root. And then what didn't come out? That 2 and that 3. So that's 3 square root 6. And now this really can't get simplified down. And now here's our simplified terms. So what looked like you wouldn't be able to add or subtract these terms because they're not the same square roots, once you've simplified them, they are the same square roots. So 4 square root 6 plus 3 root 6, that would be 7 root 6, minus 1 root 6 would be 6 root 6. Now, I've got one more for you. Again, it follows the same concept of they're both cube roots, but they're not cube roots of the same thing, or at least they aren't right now. So I can't just add the insides. I need to simplify what I can. 24 is 8 times 3. Now remember the trick for 8 when you're dealing with cube roots. You should remember that 8 is made up of 2 times 2 times 2. That just saves you a minute or two. So 24 is 2. There's a group of 3 2s and the extra 3. Now what about the x to the 7th? Remember, x to the 7th would be 1, 2, 3, 4, 5, 6, 7. Now, since we're in cube roots, we're looking for groups of 3. So there's one of them. There's a group of 3. Here's another group of 3 with an x that doesn't come out. So a 2 came out, and it joins the 5. So that makes 10. 2 times 5 is 10. X squared came out. And that's all that came out. Now I have cube root. Let's figure out what stayed in. There was a 3 that stayed in. There was an x that stayed in, and there's our one lonely y that couldn't go anywhere. Now we're going to add the other term, which is as simplified as it can possibly be. And lo and behold, these two terms are now like terms. They're both cube roots of the same thing. So I can add 10x squared plus 8x squared is 18x squared, and then cube root of 3xy. The last part of worksheet 3 starts having you do some multiplication of radical terms. And again, I'm going to start it off with a related concept. You've already done this. You've probably done it many times. Y plus 5 times y minus 5. If you wanted to, some of you, maybe many of you, have learned to do this by the FOIL method. First outside, inside, last, multiplying two binomials. If you're comfortable with the FOIL method, you could do it that way. I teach it using a little bit of a different model, the area model that I call the matrix method. But it's the same thing. You can see I put one of the binomials up here, and I put one of the binomials down the side. It doesn't matter which one you do, but it creates a 2 by 2 matrix, so I have 4 cells, and I need to multiply to get into every single cell. Now, this y times that y gives you y squared, which would be the exact same thing you did if you started FOIL. Y times y is y squared. Now in this box, I've got a y times a 5, which is a 5y. Now in this box, I've got negative 5 times a y, which is negative 5y. And in this box, I've got negative 5 times positive 5, which is negative 25. And now I would just combine like terms to simplify what we've got. Now what's going to happen on a difference of perfect squares, which is what this is. Now, these are basically the same thing with the exception one of them's a plus and one of them's a minus. So it's a difference of perfect squares. The two middle terms are always going to cancel each other in a difference of perfect squares. they're going to be opposites of each other. So when it's time to simplify, they basically wipe each other out, and you're left with y squared minus 25 as your answer. Now, the reason I reviewed that is because the exact same rules occur when it's a difference of perfect squares and it involves radicals. See how this is a difference of perfect squares? It's basically the same thing with the exception of one of them is plus 3 and the other one's minus 3. So let's do the multiplication. Square root 7 times square root 7 is the square root of 49, which is 7. Now, square root 7 times 3 is 3 square root 7, because remember, that would be considered an outside number. That's considered an inside number, and they do multiply, but that's what you get when you multiply. Now, this one, negative 3 times square root 7 is negative 3 root 7. Now, in this box, it's a negative 3 times a positive 3, which is negative 9. So what's going to happen is really nice. The two middle terms cancel each other again, just like they always do in a difference of perfect squares. The two middle terms wipe each other out. So all we're left with is the first and the last. So it would be 7 minus 9, which in this case is negative 2. So that would be the answer to that. And let's just do one more right here for practice. 2 square root 5 plus 4 times 2 square root 5 minus 4. I've got it set up in the matrix, in the 2 by 2 matrix. Now the first cell right here, 2 root 5 times 2 root 5. Remember the rule, outside times outside stays outside. So that would be 4. Now square root 5 times square root 5 would be square root 25. Inside times inside stays inside. But the square root of 25 is 5. So you would bring a 5 out. 5 times 4 is 20. So this cell really is 20. Now this one, 4 times 2 root 5 is 8 root 5. This one, negative 4 times 2 root 5 is negative 8 root 5. This one, negative 4 times positive 4 is negative 16. And one more time, you can see that the difference of perfect squares, the two middle terms cancel each other. They will always cancel each other. If they don't, you've done something wrong. So all we end up with is the first term, which would be 20, minus 16. So we're just going to combine those two terms, whatever 20 minus 16, or 20 plus negative 16, if that's the way you want to look at it. But the end result is this 20 minus that 16, which gives you 4 as your answer.